Okay, so I wanted to mention an opportunity that's coming up with SWE. I know I talk a lot about SWE, and that's because I'm an advisor of SWE. So I want to make you all aware, in case you're interested, this Friday from 12:30 to 1:30, we're going to have someone that used to be a member of SWE come in and talk to us about how it's helped them and what benefits you can get from joining SWE. So if you're interested and available, please stop by during that session. That will count towards extra credit if you haven't done that already. So it's a good opportunity. There'll be more opportunities if you can't make this one though. But I've been posting the opportunities on the discussion board. So if you haven't gotten extra credit for that, please check that and see if any of those opportunities work for you. Also, I thought this was pretty interesting. So you're all in a Java programming class. So if you look at this list, based on earning potential, the number of job openings, and overall job satisfaction, Java developer is number 1 on the list. So yay, right? And data scientist, number 2. So you can take a look at that list. I thought that was pretty interesting. So yay! I thought I had to share that since it's number 1, right? Okay. So now you can see that we are going to be going over chapter 8 today. So I decided to give you 2 weeks for this chapter because, well, it's not stopping. And go back up here for a second. 2 weeks for the chapter because it is a longer chapter with a lot of new content. We didn't meet last week just because I wanted you to have a chance to watch the lecture video and read the material, let it sink in. This time we're going to talk about some of the difficult things in the chapter, and then you have your assignment and quiz that's due this Saturday. So if you're still having trouble after today, make sure you set up an appointment to meet with me. And then next chapter, we are going to meet next week. We're only going to take a week for this chapter, and that's because this is the next chapter, chapter 9, is kind of a quick chapter. I don't think it's too difficult, so we're just going to do it in 1 week. Okay, so we will be meeting next week on that. All right, so what I want to do is I want to go ahead and pull up our Kahoot game. Does anyone have questions about the schedule? I like taking that off when I do this so that I have more room for it. Sometimes that video pops up all over the place and blocks things. So, all right, so I'm going to start up the Kahoot and see how much of the chapter made sense. So it's loading the game pin. So you can join in just a second. All right, 402-8522. Okay. Oh, I didn't know I was playing the game today. I hope I do good.
It's like you play every time.
Yeah. Okay. I like the interesting names. Okay, so we're gonna go ahead and start, but don't worry because the game number is down at the bottom, so you can still see it. So down at the bottom, as soon as the quiz question goes up, you'll see the pin. So if you still haven't joined, down at the bottom right-hand corner is the game pin. Okay, wow, good job. Okay, so this is a new method that we're talking about in this chapter. The two-string method is pretty neat because you can actually just see the name of the object, and that's a shortcut for calling it. You could say account.toString, and that would also call it, but you don't need to. If you just put the name of the object, it also calls that method. Now, one of the things you have to be aware of is there's actually a two-string method for all objects in Java. And so if you don't write your own two-string method for your class, it automatically uses the default one. And the default one we're going to take a look at in just a bit when we're done with the Kahoot game. It actually will print the class name and the reference location of the object, probably not what you want. So if you wanted to print the properties of the object, then you have to write your own toString method. Okay, does that make sense to everybody?
Mhm.
Perfect, okay. Okay, well, good job. Okay, so the JVM is the Java virtual machine, and basically if you have objects that nothing is referencing them, they can be cleaned up by the JVM automatically whenever the Java feels that it needs more space. And so that's called garbage collection. Okay, so we have quite a couple different choices that were picked here. So making an instance of one class field in another class is actually called aggregation, and it's something we're going to talk about today. So the concept is basically if you were to have an object that has other objects within it as the class field, that's aggregation. So your book talks about how a house can have like window objects, for example, or door objects. So these pieces, these objects are included within the house object. So I'm going to show you an example of that today. Your book mentions one example where you have a course and you have an instructor and you have a textbook. And so a course has an instructor and a textbook object within it. So that's aggregation. But we're going to go over another example today. So hopefully it'll make more sense. Okay, good. So if you have a static field, then you only have one copy of the field in memory. So if you think about static method, it's the same idea. So you write a static method for the class, not for an object. So when you write a static field, it's for the class, not for an object. So you only have one copy since it belongs with the class, not with every instance of the class. And so a static variable is a single copy that's shared by all the objects of the class. So you might say, well, why in the world would I do that? Wouldn't I want all my variables to go to the objects specifically, the objects themselves? If you have properties of an object, you want those to go with the individual object, but sometimes you might have something like a counter variable. And if you were to, for example, create a static counter variable, you might put that in the constructor and increment it every time you create another object. So when you call the constructor when an object is created, you would automatically increment the counter, the static counter, and then you would know you have another object. So what it would do is keep track of how many objects were created. So if you're talking about a house object, for example, a house class, and you want to know how many houses were built, if you had a number of houses, static variable, you can increment that in your constructor and it would keep track of how many houses were built. So if you built 20 houses, it would be 20, but there would only be one copy of that belongs to the class. There wouldn't be a different one for each object, for each house object, because it wouldn't make sense for each house object to have their own number of houses variable. It just have one for all the houses. So static variable belongs to the class, not to the object. Does that make sense to everybody?
Yep.
Okay, good. I'm doing pretty good. This one I couldn't fit in one question, so I had to kind of split it into two pieces. Okay, so we got all kind of answers for this one. So this was kind of a tricky question. The keyword here was static. I tried to put it in bold. It doesn't show up very bold though. So if you have a public static method named getNumberOfEmployees and an employee class and an employee object named employee1, which of the following should you use to access the getNumberOfEmployees method? So basically what you're looking at here is that this method is static. So if it's static, you don't actually use the object to access it. So if it was non-static, you would say employee1.getNumberOfEmployees. But because it's static, you would actually say the name of the class, which the class is employee. So employee class. So you would say employee.getNumberOfEmployees since it's a static method. There's not enough time. I'm sorry. Does that make sense though? Is everybody okay with that now? I know that sometimes I don't give you enough time. Sorry.
Yeah.
As long as it makes sense afterwards, that's okay. You couldn't. I know. I'm sorry. I'll have to remember that next time and add more time. Yes, that's good. See, that's all that matters is now you understand and now you can read it. Sorry. Yes, I will have to add more time. Sometimes I don't realize how long it'll take for you to read it and answer it because I know what I'm looking for. So I have to, sometimes I do it and then I say, oh, maybe that's not enough time. Sorry. I know next time. Okay, good. It should be 1. And it works just like an array. So it should be, this is 0, 1, 2. And so maple should be 1 just because you start at 0. So ordinal value is just the numbering of it, how it works. And we're going to practice enums as soon as we're finished with the quiz to make sure everyone's okay with it. Okay, so when you want to create an enum, you would say the name of the enum, and then you would give your variable a name. And then you would say the enum name again, dot whatever constant variable, whatever constant you wanted. All the constants are in capital letters because they don't change. So you would put like color.blue if you wanted blue. One of the nice things about an enum, it's a data type that contains a fixed set of constants. And so basically, if you were giving someone this color data type, they can only pick one of these 4 things in your list. And so it's good for limiting choices when people are choosing things. So, all right, so let's see how we did. And then we're going to practice enum so you can get some more practice with that. All right, good job.
How does 4/7 be followed?
All right, so I want to pull up, actually going to start a new project here. And I'm going, whoops, not new file, new project. And I'm going to write an enum with you. Put this on my desktop. Okay. And I'm going to call this, I'm going to do a season one. So we do all the seasons. So we'll call this season enum here. And then I'll write one from scratch with you. Okay, so here we are going to create an enum season. So we will actually put at the top our list, our enum. So each of the things that you want to include in your enum are constants that get capitalized. So when you're putting them in there, make sure they're capitalized. Okay, and then I could take this out. So it would look something like that if I was creating a season enum. And then if I wanted to access one of the values, I would first have to create a variable to store one of the values. So I would say something like this, season, and then I have to give it a name, a variable name. So I might call it S, for example, equals, and then it would say season. And then when I type period, it's going to come up with a list of the different choices I have, the different constants. And so I have to pick one of these constants. So I might do spring because it's spring here now, right? And then if I wanted to print off my variable I just created, I could do print line. And what could I put in there to just print my spring choice that I just made? Does anybody have any idea? How would I print off what value I chose and season I chose? S, good, yes. So what that means is that's just the object name. That's what I chose to call it up here. You could put s.toString because it's really calling the toString method on the season enum. So every enum comes with a toString method that automatically is going to give you the value of whatever you have in the object. So if I were to run this, it's actually just going to say spring. It won't say season.spring, it'll just say spring. So the toString method on an enum just prints the value that you chose. And you could say s.toString, or you could just say s, just say the object name. Another cool thing you can do is you can use your for each loop. So I could say something like this. There's a method called values that will actually go through the values in your loop. So I could do something like this, system.out.print, and I could say v, and I could do like a space there. Now I didn't use print line because I didn't want them on separate lines. So I just did print and I put a space between them. So if I go through, what's happening is it'll go through the list of values. Okay, it'll make this work as like an array so that you can go through the values and save them in V and print each one out. So if you were to run it, it would actually just print all my values here. And I didn't put print line, so it's all in one line with a space between. But this values method allows you to basically treat your enum, it's a special class, as an array. Okay, so another thing you can do is you can actually put this in a separate file. And when you go to new file, you could choose Java class and just erase everything that's in there and put your enum statement in there. So if you were to just actually copy this line, you could just create a new class and paste it in there and that would work fine. But you would have to, you would have to delete everything in the public class because you don't actually put public class in there. Or if you just actually copy your values and you do new file, there's actually one called Java enum, which I actually didn't use before. I used to just delete everything in the class. But this is pretty cool. You can write season up here and it does the work for you. I mean, it's not that much work, but you would just paste your values in here. So I could just have said new class file and then pasted my enum over top of it. But this is nice because it kind of sets up the enum for you, so you don't have to do that. And then if I comment out this enum that I put in this class, I can do it as a separate file. And the benefit of that, it does the same thing. The benefit of that is it can actually make this so that it can transfer into other projects easier if it's a separate file. So you could put it in the same file, it's fine. Or you can put it in a separate file. So it works as like a special class that allows you to have a data type of your own with your own constants in there. So it can be in this class with this one, or it can be over here. as a separate one. Does that make sense to everybody? You all okay with that? Any questions on enums?
Not really.
Okay, so hopefully you get to have some fun with that. Another thing I wanted to talk to you about was the toString method and the equals method. So I created this little basic project here. And if you look, there's a circle class. The circle class just has one field, a diameter. The constructor is going to set the diameter. There's a set diameter in case you want to change it, and a get diameter to retrieve the diameter. And then I created this get circumference. And what that does is it actually multiplies the diameter times pi. I could write down 3.14, or I could do this. Java actually has a variable, a constant called pi, inside the math class that we can use. So I don't ever have to remember what pi is, because it seems like I can only remember 3.14 and I don't know the rest of it. But if you know like the 16 digits for pi, decimal number, then by all means you can type it in there. But if you don't know it, then you can just type math.pi. Now, if I did 3.14, it would be accurate enough for what I'm doing here. But if you knew more numbers after that, you could type them in, or you can just use this in place of it. And this will pull it for you and tell you. I think that's why I never remember it, because I don't have to, because I have this available to me. So, okay.
Question.
Yes.
Do you know how many decimal places that's rounded to? What data type is that pi?
Double. It gives you 16.
Okay, thank you.
Yeah, so it won't give you as many as pi, but it gives you 16 is usually accurate enough to do whatever you're doing. And way more accurate than my 3.14, since that's all I know.
3.14 is what they use in most math classes anyway.
Yeah, we never had to learn any more than that, so I guess I never bothered to learn any more decimals after that. So
Unless
this
you're
one
an
is pretty
engineer, in
helpful.
which case it's just 3.
Yeah.
Mood.
Okay, so what this does is this creates two circles, a circle, a C object and a C2 object. I'm going to make these the same actually. And then this is going to use the toString method on C and a toString on C2. But I didn't actually create a toString method, so I want you to see what happens. And then it's going to use Java's original equals method to see if they're equals, if they're equal. Okay. So see what happens here? When it prints off C, when it uses the toString object, it actually prints the name of the class and then a reference location. And same thing for the second one. And you can see that the reference locations are different for each of those objects, since they're two different objects. Now, if you were to actually take C and put it into C2, you would see that they're actually the same reference location. And most of the time you don't want to do that, because most of the time you don't want to reference the original, because then if you change it, you're changing the original. So it's most of the time it's more beneficial to create a new object that has a different reference location. But the reason why it says they're not equal, even though they are the same equal diameter, is because they're not in the same reference location. So actually, did you see, I didn't point it out, it did say true, but did you see when I left it at C, when they referenced the same location, it did say true here? Did you see that?
Yes.
Okay, so, but when I change it, it says false. So what I'm getting at is there is a toString method and an equals method that's part of an object class in Java, and every object in Java inherits from this class. We haven't talked about that yet, but basically it gets these methods. So your job is to override their methods that they have to make it fit your program. So if you create your own toString method, what do you think toString returns? What data type?
A string.
A string, good. And you have to name it toString. And the reason is because it's going to override the toString that they have. So one thing it's saying here is you want to add the override annotation. And I like adding this because two reasons. It tells someone that you meant to override the toString Java had, and it also stops someone from changing the name. See how you get an error now? If you don't put that annotation on there, if someone changes the name, it doesn't matter. It doesn't say anything. But if you put this, it actually stops someone from changing the name. It says that it's an error. Now it's telling me I'm missing a return, but that's the next thing I was going to do. So now in here, you can put whatever you want. You can say like diameter of circle, however you want to word this, whatever formatting you want to use. this is where you would put it. So I would put like diameter plus, and then I would do something like this. I would put it on another line. And this is just how I do it, but you could do it a different way. You can use the string dot format. You can actually format the number of decimal places, because one bad thing about this is it's going to give you 16-digit decimal places. So instead of wasting your time now, I know that y'all know how to do that because we practiced that a bit. If you want to, you could do that later. You could do something like this, and you'd want to format the diameter and the circumference to have 2 decimal places or 3, something you don't want 16. But for now, I just want to show you that this causes it to use your toString, okay, for each of them. And you can see that they're the same because they have the same diameter, but it's still saying false for the equals, and that's because it's still using the old equals. Okay, now another thing that I wanted to talk to you about is you could use the reference variable this in here. Some people like that and some people don't. It's not necessary, but you can use it. So when you're saying, basically you're saying which diameter, you're saying this diameter, the object that you're currently using, and you're saying like, which object would you like to call the get circumference method on? And in this case, this object, the current one, is the one I'm calling it on. So that when you go over here and you say like, C here, C is this. So it knows to do like the diameter of C and the circumference of C, because that's the current variable you're using. That's the current object that you're using. Does that make sense to everybody?
Mhm.
Okay with that? Okay. So now if you wanted to write an equals method, this is tricky. What data type does equals method return?
Boolean.
Boolean, perfect. Thank you. Okay, equals. All right. Now, in order to compare one object to another object, we need to pass in another object. So how do I pass in a circle object? Anybody know?
I'm assuming
when
you just pass it a circle object and then give it a parameter name.
Yeah, what parameter name you want to give it? Anything you want.
R.
I'd probably choose a circle.
So you want to call it circle? Okay, that works.
For parameters, I'll usually preface the parameter name with a P, so I'd call it P circle in camel case. That's
Sure.
just my preferences then.
Yeah. The only thing I want to say is I don't, yeah, I like this. This is fine. If I call it C, I don't want you to get confused. Like if I were to change it to C, I don't want you to think that it only works with C. Like it works with C too. So whatever name you decide to use over here, that doesn't impact the names that you chose over here for your circles. I don't want you to think it only works with those names. So it is good that we called it circle and not C, because I was worried if you called it C, you might think it only works with C, and it really has no impact. You can call this circle C over here, and this variable could be called C, and it's just a variable name. So it really just puts the data from the one into the other. It doesn't matter if they have the same name or not. So I wanted to, because I know that is kind of tricky sometimes when you think about it. So if we're going to start with the first diameter, so the first diameter is the object you call it on. So when you say C dot equals the current object is C. So that would actually be C here. That would be that diameter of C. And we want to compare it to see if the diameters are equal. So does anybody remember what I can use to see if they're equal for doubles when you're comparing doubles?
Can you use like equal?
Perfect, thank you. And then I'm going to use the circle variable that we created right here for diameter, okay? Yep, and you can completely give it a new name if you want to. If you want to call it like P circle or PC, you know, for parameter circle, that's fine. You don't necessarily need to curly brace this since you're only going to have one line. So we'll say return true here, since we know that they're equal, then they're equal. We only need to compare the diameters for the circle. Sometimes we need to compare more, but for this one, we only need the one variable. Now Java's upset with me. It says I'm missing a return. Anytime you have a conditional that has a, if, but it doesn't have an else, it's going to be upset with you because it doesn't know what to return if the if isn't true. But we need an else anyways, because this only tells you if they're equal, but it doesn't tell you what to do if they're not equal. So Java's right, we should have an else on there. And so it should look something like this. Does that work for everybody? that make sense?
I do notice your IDE on the side is suggesting that you could, I think, simplify a thing. Is that too complicated, or can we get into that?
No, you can do that. You can simplify it. You can do that. So what that's doing is basically saying if they're equal, return true. If you want to simplify it like that, that's fine. I didn't know if that would work for everybody, but yeah, you could do that.
All right, thanks.
And that's just a suggestion, so I don't have to do it. Anytime you see the light bulb, it's just like a, hey, you can do it this way type thing. You only have to worry about red. You should look at yellow to see what it's saying, because maybe there is a better way to do it. Like sometimes if you're doing conditionals, it'll say like, did you want to use a switch instead? And this one's saying you could simplify it. You could do this, because basically if this comes out to be true, it will return true. Otherwise it'll return false. So it knows to do that. Otherwise you don't need to have the if. So whatever way works for you. Yeah, that's great. Okay. So now that's all I needed to do. And now if I run it, it's going to say true here. It's going to say they're equal because they have the same diameter. So they're not the same object. They don't have the same reference location, but they do have the same diameter. So when you compare their diameters, this equals method overrides the equals that Java has and compares their diameters instead of the reference location. Now, if I change their diameter, it's going to tell me false. So you can see that that works. And I'll have different information for each of them. So I see false here. Okay, so does that make sense to everybody?
Made sense to me.
Perfect. We are going to do a breakout session later where we practice that. So we'll see how much it makes sense. Okay, so the last thing I want to do with you before we do our breakout is I want to talk about aggregation, because aggregation is kind of a hard thing to understand as far as coding goes. So what I want to do is I want to talk about a parking ticket. If we're talking about getting a parking ticket, we need to have a parked car, first of all, a parking meter, a police officer that's going to write the ticket, and then we need to have the actual parking ticket. So let's take a look at these UML diagrams I have so we can talk about what's going on. So if I have a parked car, here's some information you might want to know about the car. What's the make of the car, the model, the color, the license number, and then how many minutes was the car parked? Because I have to find out if they are parking illegally by not paying for the meter, right? So I have a constructor, and the constructor is going to basically set all these variables. This is something new that's kind of confusing. The second constructor is a copy constructor. So what's a copy constructor? Well, when we're doing aggregation and we're going to have the object from one class become the field of another class, instead of actually just, referencing the same object, you create new objects for that. And so an easy way to create new objects is to use a copy constructor to do that. And the reason why you don't want to reference originals is because you don't want to modify the original. That's a good way to have a security problem, is to have everything referencing the same original copy and be having different places where you modify it. So instead of doing that, if you just make a copy of it, you have the same information, but you're not modifying the original one. And so that's what we're going to take a look at in the code today. I didn't have the setters and getters on here because we've seen that last week and we know how that works. And so just to kind of focus on everything else. The toString method is something new this week that's going to basically format the output nicely for us. And so there's where you can worry about how many decimals you have and what exactly you want it to say, how you want it to look. Okay, so let's take a look at the code for that. So we have a parked car. We have all of our private fields at the top. Okay, we have our basic constructor, which sets everything. This is our copy constructor, which is if you pass in a car, it will take all of the fields for the car you passed in, copy them, and put them in the new object. Okay, and then all of the setters and getters, which we talked about before, so those should look familiar, hopefully. There's a lot of them, so we're not going to talk about all of those. And then the toString, you can use the string format method, or you can just do like a string and put it how you want it to display with the using the decimal format if you want to format the number of decimals. However, whichever way is easiest for you. Okay, so this is an example of a toString with all the car information. Is everybody okay so far?
Yep.
All right, now we have our parking meter. This one's very easy. Okay, so the parking meter doesn't have very much. The minutes that you purchased, just a basic constructor to do that. And then you can set the minutes and get the minutes. So very simple, right? Okay, so if you look at the code, the parking meter just has your minutes. It has the constructor and it has a setter and getter for the minutes. Okay, so very, very basic. Okay, so let's take a look at the police officer. So the police officer has a name and a badge number. And then it has a constructor that sets those fields. It has a copy constructor in case you want to copy and create a new police officer. It has this new method called patrol. I'm going to take a look at that in a second. All the setters and getters aren't listed on here. It would just be actually these two fields for setters and getters. And in a toString that prints all the police officer information. So the patrol is where you're actually going to issue the parking ticket. And we haven't talked about the parking ticket class yet. But without talking about it, if you think about it, if a police officer is patrolling, it has to know the car, it has to know the parking meter information, and then it can issue a ticket. So the object it's sending back is the parking ticket. Okay, so let's take a look at the class for the police officer. So we have the fields at the top, the constructor, the copy one, and the regular one that sets the fields. We have the setters and getters for the fields. And then I want to take a look at this patrol method because this one's new. Okay, so, and it does have a toString, and that's very basic. Okay, so the patrol method is something I want to focus on. So for the patrol method, you're actually passing in a car object and a parking meter object. And you want to pass in these objects because, well, let's skip this and talk about this in just a second. Because you're going to take the number of minutes for the car minus the number of minutes that you purchased at the meter. Okay, and then that will determine how many legal minutes you have. Okay, so does everybody see how that works? You pass in a car and a meter and you can get the minutes from both of those to figure out how many legal minutes you have. Then if the number of legal minutes is greater than 0, then we're going to create a parking ticket, which we'll take a look at in just a second when we create a ticket. So if the parking ticket is going to need the car information, it's going to need the officer information. So this represents officer in this case because you're in the police officer class. So when you do the patrol method, you call the method on an officer, and this represents the officer. And then the number of legal minutes, which was calculated here. So this will create a ticket and save it in ticket, and then return the ticket. Now, what happens if this isn't true? Well, then it's going to return null because the parking ticket was originally set at null. So if it doesn't match this, it doesn't create a ticket and it returns null. Does that make sense to everybody?
Yep.
Perfect. Now comes the aggregation part. So it looks a little overwhelming, but bear with me. We already talked about the parked car and the police officer. So this is the new one, the parking ticket. This little diamond here in the UML represents aggregation. It means that basically this parked car class and this police officer class, the instances of those classes are going to become fields in this class. So you see here, the car is actually a field in the parking ticket, and so is the officer. So that's what that means. If you have an instance of a class that's a field of another class, that's called aggregation. Okay? Then we have some new fields. We have a fine field, which is we're going to calculate the fine. How many minutes you were illegally parked will be in there, so we can determine what the fine is. And then we'll have a base fine, which you can make up whatever number you want. This is a constant, so it doesn't change. Once you set it, it stays there. And then an hourly fine, which will be used to calculate the fine, which you can set it whatever you want. Okay? And then you'll have a constructor, except the constructor looks a little different because the constructor is passing in an actual car and a police officer and the minutes. Okay? And then we'll have a copy constructor, and then the calculate fine, which we're going to look at in detail in just a second. And then, of course, a toString, which will print all the information of the parking ticket. Are y'all with me so far?
Yeah.
Okay. So let's go to the parking ticket. See how the parking ticket actually has an object up here that's from the parked car and one from the police officer? I want to talk about this for a second. And here's our constant fields up here for the base fine and the hour. hourly fine. When we're doing this constructor, notice here you pass in a car and you pass in a police officer. But here, when I'm creating putting it in the car variable, you notice that I don't do this. I don't say car equals a car. Because what this would do, we've been talking about it a little bit, would actually reference the original car. So if you're going to save the information from a car into car, you're actually referencing a car. So that car actually references a car. And the bad part about doing that is if you change the fields in car, you're actually changing the fields in a car as well, because they're both referencing the same object. And a lot of times they tell you not to do that because every time you allow people to access things, you give more people permission, you end up with security problems, right? So you want to make sure that instead of accessing the original, that you do it this way. And what this does is it actually copies the same information from a car and creates a new object with it. So it references the new object instead of the old object. So how does it do that? How does it know how to copy it? Well, over here in parked car is where you have that copy constructor. So if you go to this copy constructor for parked car, it actually takes in whatever car you're passing in, and it takes all the fields and saves them into the new object fields. So what you're doing is, it ends up doing the same thing, but the difference is one's referencing the original and one's referencing a new object. So that if you make changes to the fields, if you have a new object, you're just changing that, you're not changing the original. So you have to watch. And I mean, sometimes you might want to do that and sometimes you might not, because the more times you reference the original, the more likely it is that things are going to get changed that you don't want to get changed, and there might be problems in the future. So it'll still have the same values, but do you want it to actually change the original? You have to watch how you program that. And so that's what you decide over here when you're doing, oops, where's my parking? Here's my parking ticket. That's what that's doing here. And same thing with the police officer. Instead of actually referencing an officer, you're actually creating a new object to save this information into, so that when you do it this way, you can do the copy constructor with it. Okay. Is everybody okay with the copy constructor? Did you want to see the police officer copy constructor over here? So police officer here, it would pass in the police officer, and that would take the field from whatever officer you pass in and save it in the field for the new object. And same thing with the badge number. Does that make sense to everybody? Did I lose everybody?
Makes sense to me.
Okay, perfect. I'm
I have
not
a
sure.
question. Excuse me.
Okay,
So
so
why do we have like 2 officers and 2 parked cars? That's what I don't understand.
why do you have 2 of them? Well, so when you're doing the parking ticket, you need to know the car that you're writing the ticket for, and you need to know the officer that's writing the ticket. So the reason why you're creating a new parked car and a new police officer to save the information into your class, your fields, is because if you reference, the officer, let's do this one since I did the other one last time. If you say something like this, that would take the information. Oops. This would work because it would take the police officer that comes in when you're creating the parking ticket, you're passing in a police officer. Okay. It would take this police officer that's being passed in, and it would save that information into the officer. Okay. But if you were to modify that information, it would modify the original, and you might not want that to happen, because now every time you change this file, you're also changing the other one.
And in the
you
previous
might not want that.
classes,
What's that?
in the previous classes, in the police officer, the Java, like
Yes,
we
you're
have
modifying
officer
the
1 and officer 2. Like we have 2 different officers, right?
No, I don't have 2 police officers. So I didn't get there yet. I didn't actually create any objects yet. So over here in this is the parking simulators where I create the objects. So I actually only created 1 police officer here. Joe Friday is the officer. I could have created more, but there's only 1 parked car, 1 parking meter, and 1 officer in this particular example. So in the main class, or in the main method in this class, is where you actually create the objects. So I'm not actually creating any objects over here. I'm just allowing it to work. Whereas when I create the objects, this is what happens. Instead of when it creates the object and uses it, that it doesn't reference the original. That's how this is programmed to be. so that it doesn't reference the original car and make changes to it. So whenever you're creating a parking ticket, you don't want to make changes to the original car or the original officer that you had. So this creates a new car and a new officer. So if you make changes, you make changes to your new copy instead of the original. I know that's kind of a lot to take in. Does that make sense?
Makes sense.
I'm going to give you these files. I'll put them on Canvas for you. Okay, the copy constructor's purpose is to also prevent the original. Yes, yes, that's the purpose of it. Yes, so when you do aggregation, you want to watch out for security. And so one of the things with security is that you make copy constructors, and the purpose of the copy constructors is that when you're using these other objects in your code, you're not referencing the original. You're making, they call them deep copies. You're just taking the information from the object you have and creating a new object with it. So you're not modifying the original object. And that's good programming practice, just because if you allow people to modify everything, if you think about it this way, the more permission that you give people, the more likely thing is something's going to happen, right? If you give everybody permission to everything, that creates lots of issues, right? You want to think about what permissions you want to give certain people, because giving everybody all permissions, if you think about that just in general, that creates problems, right? So the more classes you allow to modify your objects, the more likely it is that you might have problems in the future with something changing the original. And there's other examples of why you wouldn't want that to happen. So a lot of times you don't want it to modify the original. So that's what this copy constructor is doing, just because it can create problems. Okay, good. So I know it's kind of a new thing, but I'm going to post this project with all the UML on Canvas just under the chapter 8, so you have it, so you all can play around with it and take a look at it. You can also, I'm recording this video, so you can also rewatch this video. But if you want to schedule a one-on-one meeting with me, if it's still really confusing, but you don't want to say anything right now, that's fine. I can work with you one-on-one on it too. But I just wanted to give you another example, because your book has one with a course, and an instructor, and a textbook. And you only really have that one example to get it, to get what aggregation is, that a course has an instructor and a textbook. But I thought this one was a little more involved, and so you can see another example of, what's going on. So hopefully it gives you, more insight into how it works. So the minutes are the illegal minutes. So you can figure, when you do the calculate fine, you set the minutes for the parking ticket up here, so that when you do the calculate fine method here, it knows that minutes are actually the legal minutes, okay? Oh, where's my calculate fine? I have to scroll down a bit more. So minutes are actually the legal minutes that was set for the parking ticket. So if I want to go here, let's say that my illegal minutes are 100, okay? Everybody following? So I say hours equals, if I take 100 divided by 60.0, I get the decimal answer, so I get something like this. Okay, I'm not going to put all the sixes on there, but are y'all with me?
Yeah.
Hours equals 1.66666616 of those. And then hours as int. Now what this is doing is actually taking the hours variable and it's casting it to an int. So if I cast that to an int, does anybody know what it would be?
It would be 1.
1, good. Don't round it, just cast it. So just chop it, it becomes 1. Good job. All right, so if I take the hours minus hours as int in my conditional here, so if I take 1.66666 minus 1, I get 0.66666. And if I'm comparing that to see if it's greater than 0, it is. And so what it's going to do is it's going to increment my hours as int variable. So what you're doing is you're trying to, whoops, if I increment it's 2, sorry. That was the one from up here. So I increment it 1 time, it becomes 2. So basically what you're saying is, okay, you're trying to figure out how many hours. So you divide by 60. But if there's a little bit of time left, you're going to go ahead and add on another hour. So they're being really harsh here, right? For calculating how much you owe. So when you calculate how much you owe, you're going to be based on per hour, not per minute. So then the fine was originally established in this base fine. And you can change that to whatever you want. But the base fine up here, this constant is 25. Okay? So if I go back down here, this base fine is 25. Okay? Then if I take hours as int, and multiply that times the hourly fine. So the hourly fine is up here, is 10. And you can change that if you want to. So hourly fine is 10. And I'm going to take that times hours as int, which is 2. So I'll take 2 times 10, which is 20. And I'm going to add that to the fine. So if I add 20 to the fine, I get 45. Does everybody see that? This means, this plus equals means take whatever the fine was previously, which is 25, and add 20 to it because I took the 2 times 10. Are y'all okay? Did I go too fast?
Wait, where are you getting the 10 from?
2.
Oh.
So hours as int was 2, and then I took it times 10, which is the hourly fine. So that gives you 20. And then I add the 20 to the 25 I had, and I get 45. So if I were to stay 100 illegal minutes, let's say, if I'm parked at a meter for 100 minutes illegally, how much would I pay? So I'm going to run it with that information and see what it says. See, it should come up with 45 as a fine. So here's my car information, here's my officer information, and I was parked illegally for 100 minutes, I paid $45. Okay, so where is it pulling this information from? Well, if I go here to the simulator, here's my parked car, here's my parking meter. So my parked car, this is the number of minutes I was parked. And this is the number of minutes I paid for. If I want to actually pay for some of those, let's say I'm going to pay for my 100 minutes, what happens? Here's my police officer. So if I pay for my minutes, it says no crimes committed. Because here's how it works. When it actually does this patrol method, on whatever officer you have, I only have one officer here. When it does the patrol method, it sends in the car and the meter. So if you go to the officer and you go to the patrol, it passes in the car and the meter, and remember it subtracts them to see how many. So if you had 100 and 100, it'll say 0, and then it won't match this. And if it doesn't, if this isn't true, then remember the parking ticket is null. And if it returns null, then it's not going to print off. So over here, I have, if the ticket is not equal to null, print the ticket, but otherwise print no crimes committed. So if the ticket ends up being null, then it says no crimes committed. Okay, so if it's not, 0, if it's not greater than 0 for the illegal minutes, then it's going to say no crimes committed. Okay, does that make sense?
Yeah.
That makes sense.
Okay, does anybody have any questions?
Is this gonna be our assignment? Like, this is what we're gonna be doing?
No, you're going to focus more on the toString and the equals, but I wanted to make sure that you understood aggregation because it's kind of hard to, it's a big project, right? I want you to understand exactly what's going on. So I wanted to give you another project because your book only gives you one example. And I didn't have an exercise for this chapter because I think it would be a lot to type all of this in. So I just wanted to give you an example. And you have the video, you can play around with this and add whatever you want to understand aggregation. But no, your assignment is not going to be aggregation. It's going to be more of writing your toString and equals, which is what we're going to practice in our breakout session in just a minute. But before I do that, does anybody have questions about this particular project?
Professor,
Yes.
know about this, about the enum. So when we use the enum, does it mean we create an object or we are going to use the class?
Say that again, I'm sorry.
So I mean the enum, whenever we use the enum, right? So we're going to create an object.
So when you do the enum, it's kind of like a special class. You're creating a data type, but it acts as a special class. So you put enum and then you put your enum name, which is like your class name, and then you put your constants that you want for your enum. And what happens is when you want to use it, you just put the enum or class name, and then you put the name of the constant you want, like dot the name of the constant. So it works as kind of like a special class for creating data types, so that if you want people to choose from a specific list of options. Like we had for season, we had 4 options. We don't want people making up their own thing, because if you just have like string season and you have people type in a season, then they can put whatever they want. They can make up their own season. But if you want to restrict them to be one of the seasons you have, the enum is great for that, for restricting people to only type one of the ones that you have.
And the
I'm not
enum,
sure if that answers your
we
question.
do not need to create a class like before, right?
You don't have to, so you can do it. If I go back to the season one, you don't have to create a separate class. I did to show you can, but you don't have to. So like I did here, create this one, but you could completely just use this in this class and not do the other one. Now it's going to be upset with me, so I'd have to delete this one. If I delete this, then that one's fine. If I want to, and then sometimes you have to save it to get it to work. Sometimes it gets stuck in like error mode, and if you just do Control S or save, it gets it you know, refreshes itself and it gets out of the error mode. But you can leave this in the class with this one. If the enum is part of another object, don't put it in the inside this class. Like don't put it here. But if it's not part of another class, which it's not, you can put it here too. But I would just always put it up here outside of the class instead of inside this other class, because if it does end up being part of another object, then you don't want it to be inside this class. Okay, or you can put it in its own separate class if you want to. Either
Makes
way.
sense.
All right. Okay, so I'm going to post the parking ticket so that you have, I'll post these 2 zip folders for you on Canvas so you have that. I want to go over the breakout session directions for you. Hopefully it helps you practice for what you have to do for the assignment. Is there a way we could use the equal method or a 2-string method in the main class? No, so those have to belong with the object that you're creating, like whatever class you're, so if you're doing the equals method for like to see if houses are the same, then it has to go in the house class. The equals method in the 2-string, it has to belong with the class that you're creating the object from, not the one with the main method.
I could be wrong, but I think they're asking about a way to actually use those methods, implement them in the main class, just to see an example of them.
In the main, yeah, we did that in the circle one. If that's so we did the so if you look, and it would help if I pulled this up instead of trying to explain it in words. So if you look at this one, we created the 2-string and the equals. So you're going to want this to be in the circle class in the circle file, because you use these methods on the circles that you create. So they have to go in the circle class, not in this circle simulator class where the main method is. But you use them from the main method. You can use them from the main method. Now you don't have to, but you can. So I did here. So this actually is just 2-string. It's just that you don't have to write 2-string. You can just write the name of the object. But these are actually using the 2-string methods, and you can write it if you want to, but you don't have to. It's if you just say the name of the object in a printout, it automatically defaults to do the 2-string method. So this is an example of using the 2-string and equals method in the main method, but you can't put those methods inside this class. They have to go with the object, because you're actually creating circle objects here that come from the circle blueprint class. So this circle is a blueprint for creating circles. It tells you what properties a circle has, all the methods that it has, and the methods 2-string and equals are part of the methods that a circle has. And so they have to go in the circle class, not in this class.
So what happened if we like use the 2-string method like in the main class and we don't have like another class? Is it gonna hear?
You can't put it in here. You want to put it in here. You want to put it in the, because the 2-string is used on an object, it has to go with the class that implements the object. And the
Mhm.
equal is the same thing, because what's going to happen is the circle, you can't see it, but all objects that you create automatically inherit from an objects class, and they have a 2-string and an equals, and we'll talk about this in chapter 10. They have a 2-string and equals method. You don't see that it's doing that. It automatically does that. You don't have to put anything. But this circle class automatically gets all the methods that the the objects class gets, because you're creating an object of the circle. So because the toString and the equals go with the circle objects, they have to go in the circle class, not in this one. Is just used to actually create the objects and use the methods for the objects, but you don't want to put the methods that go with the objects in here, since this is what's telling you all about a circle. This is the definition of a circle. They have to go in the circle class, which defines everything about a circle. How to tell if circles are equal, how to tell what you want to print for a circle. That's all part of the circle, not part of the main class, if that helps. Does that help?
Yeah, he did.
Okay, I know it's very tricky. I can post this example too if you want. I can zip that and put that on Canvas, and then anyone that needs it can have it. I'll put that there so you can practice. I like you to have more examples to practice with. I know your book has a bunch, but I'm just trying to give you some extra ones too. So I will zip this and put that there. I can also zip the season one too. I'll just zip them all and put them there in case you want them, okay?
Yeah, I mean, my concern was like, is there like a way to, I don't know, to override like the basic or the default toString method that come with an object?
Yeah,
I mean,
it
if we
automatically
didn't,
does. Yeah, this one does. See, this one automatically overrides the toString method. So remember when I did this the first time, like when I didn't have this, remember that when I didn't have these two methods, I
yeah,
ran it still works, even though I don't have these methods. And you're probably saying, well, you don't have a toString or equals method because I just commented them out, but it still works, but it doesn't work the way I want it to, because see, it defaults to the original Java one, but when I put mine override theirs, and then it uses mine, not theirs. And so, yes, automatically it will go to their toString and equals, but most of the time that's not what you want. So you have to override theirs. And so that causes this to work the way I want it to. Because if you think about it, Java doesn't know what properties your class has, and it doesn't know which ones are important. Like maybe I have an area and a radius variable in my circle, but I really only need the diameter to see if they're equal. So Java doesn't know which variables to compare to see if the objects are equal. So it just compares the reference location. That's the basic one it does. But if you wanted to compare their diameter, you need to write the code to do that. And that's what you did here, is compare the diameter. Now, if I had an area variable and I had a radius variable, I wouldn't need to compare those. I only need the diameter. So you're making the decisions as to what's important to say the objects are equal. Which properties do you have to compare to say they're equal? And then the toString, you get to pick how you want it to display. What formatting do you want it to have? What's the wording you want to have? You know, if you let Java pick, it just does the class and the reference location, but you don't probably want that. You probably want to display the information about the object's fields. And so how you want to display that is what you put in your toString method, but that has to go with the class that you're creating the object from, not in the main one. Okay. All right. So you're going to practice this actually. So that was good that we talked about that for a while, because I want you to practice that with this breakout room session, and then you can talk amongst each other. So maybe sometimes it's good to get other people's opinions, because I might just keep saying the same thing that makes sense to me, and maybe somebody else has a different way to describe it. So make sure you take advantage of, you know, when you're in the breakout room sessions, if you're not sure, ask your classmates, because they probably have a different explanation for it. So it's a great time to communicate with each other and get other people's take on different things, and to see if everything's making sense. So what I want you to do is I want you to create a land track class. So preferably if you would use Eclipse or NetBeans to do this, because they're great for doing projects since you need two different classes. You're going to have two fields, a length and a width, and a constructor that sets the length and width. Then a get area method, which does the calculation, just multiplies the length times the width to get the area. And an equals method and a toString method. Now, if you have extra time and you want to put a set length and a set width and a get length and a get width in there, you can, but you don't have to, because we already practiced that in the last session. So don't worry about the setters and getters for the length and the width in this one, unless you have extra time and want to add that. But I think this is more important that you understand these four methods. So focus on those four. I don't want you to spend all your time on the setters and getters, since we already covered that. So then I want you to create a class that has the main method that will create two different land track objects with two different dimensions. and then display the information about the tracks. This would be the toString method, and then compare if they're equal. That's the equals method to test it out. Okay, so get the class written first, and then do the main method that tests it all out. Okay, so what we're gonna do is we're gonna split into groups, and when you finish, I will be around checking on you. I want to see your project before you go, but if you finish and nobody has questions, then you're free to go as soon as your group finishes. But let me see it first before you take off for the day. Just want to make sure that it is correct and that nobody has any questions about it, okay? So I also want to show you actually one more thing. If this might help. So you might want to take a screenshot of the directions and the UML. So first, let me leave this on here. You might want to take a screenshot of that so you have it. I can actually copy and paste it in the chat too. Put it in here in the chat. Hold on. Chat. I put it in the chat for you so you have it, but you can also take a screenshot. And then I'm going to bring up the UML diagram. So the UML diagram might be another way of visualizing it. You have the two variables, the two fields. These are your instance variables. They're both private. You have your constructor, which is going to set your length and your width. A get area method, which is going to multiply the length times the width and return it. An equals method to compare two land tracks, and a toString to format everything and print it out. So if you want to take a screenshot of that, this might be an easier way to look at what you're supposed to do instead of reading that long description. But I'm going to split you into groups while you're doing that. Does anybody have questions on what you have to do?